In this video, we are going to look at the introduction to organic chemistry. Now, under this video, we'll look at the alkenes. Alkenes are defined as the family that contains of hydrocarbons with at least one double bond. Now, the other thing that we need to know, or maybe the characteristics that we need to know that are associated with alkenes, that these alkenes, they are unsaturated. So if we say a molecule is unsaturated, this simply means that it has at least one double bond or triple bond. So for example, if we have C here, if we have this double bond here, this is unsaturated. Also, we may have a triple bond. Also, this is unsaturated. Then for saturated, we said saturated has a single bond. Now we can move on to the next property. The other property is the names of these molecules. Their names ends in E-N-E. So we have like ethene, propene, butene, pentene, etc. Then from there, we can also look at the formula that these molecules obey. So the general formula for alkenes is CN H2N. Okay, now from there, since we have some basics, now let's look at how we can write the molecular formula and the structural formula given the name of a molecule without the location or the locant of the double bond. So let's first begin with the ethene. So you need to first have in mind that under alkenes, we start from the second one, which is ethene. Then we have propene. Then we look at butene. Then up to pentene. Now from there, we need first to have this in mind. There is what we call the prefix. So the prefix helps us to identify the number of carbons a molecule has. So we'll begin with meth. So meth has one carbon. Eth has 2 carbons. Prop 3 carbons. But 4. Pent 5. Hex 6. Hept 7. Oct 8. Non 9. Dec will have 10. Now, upon knowing these prefixes, let's first look at now how can we write the molecular formula for ethene. Now here we can see that there are no numbers, so we can just ignore the position of the double bond. So we'll first begin by, we need to write the general formula. So all the molecules from this family obey to the general formula. We'll have CN H2N. Now here let's break this name into 2 parts. So the first one, we can see we have Eth. Then ENA indicates that this molecule is coming from the family of alkenes. Now for Eth, we can see that we have the double bond here. So where there is any, we put 2. Then also 2 here. So C times 2, we have a 2 here. Then 2 times 2, we have 4. So the molecular formula for an ethene is C2H4. Now, since we have the molecular formula, we can now draw the structural formula. So we'll first begin by writing the carbons. So we have carbons here. Now, we said under alkenes, we need to have a double bond, at least a double bond between the carbon atoms. So we can see that this carbon has 2 bonds. Also, this carbon has 2 bonds. So the bonds between the carbon atoms must be counted on each carbon respectively. Now for this carbon, we can see that we only have 2 bonds remaining. Also here 2 bonds remaining. So this is where our 4 hydrogen must be indicated. So this is the structure. Now we can move on to propene. So for propene, we'll first see the same way. We'll now write the chemical general formula, which is CnH2n. Now propene, we can see that here we are dealing with 3 carbons. So we put 3 where there is any. So C times 3 is C3. 2 times 3, that is 6. So the chemical formula is C3H6. Now let's look at the structural formula. So the structural formula, we'll look at, we need to first begin, we write the 3 carbons that we have. Now, since we have not been given the position of the double bond, we can put anywhere. So if we want, we can put it here, or if you want, we can put the double bond here, since the number is not given. So say this is where our double bond is, then this one, we can see that it has the 4 complete double bonds. Then here we are going to have a single bond. Then here we'll have another single bond. So the carbon, the middle carbon has 4 bonds. Then we will need to put another 3 bonds for it to have 4 bonds. Remember, each carbon must have 4 bonds. Then here we are going to put the 6 hydrogens that we have. So this is now how you can write the molecular formula and the structural formula. So you can feel free, pause the video, take a minute and try to answer the Roman number 3 and 4. Okay, now let's see, continue. So we can now also answer the third one. So the general formula is Cn2n. So this time from the word but, we can see that but here we are dealing with 4 carbons, so n is equal to 4. So if we multiply, C times 4 is C4. 2 times 4, that is 8. Now, since we only have one ENE, this indicates that we are only going to have one double bond. So let's have 1, 2, 3, 4. Even here we can put wherever we feel like. So let's say we put our double bond here. So this is complete. Then also we can see that each carbon has the 4 bonds that it needs. Then the remaining part is where we are going to put the hydrogen atoms. Okay, so now for the last one, we have pentene. For pentene, we look at the first prefix here, pent. So pent, we have 5, so this means that n is equal to 5. So we have Cn to n. Then C5 here to 5 here. So C times 5 is C5. 2 times 5 is 10 hydrogen. Now, from there we can draw the structure. So here we have it, 1, 2, 3, 4, 5. So we can put our double bond here. So this one has 4 bonds also here. Then we have our 10 hydrogens. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is how to write the molecular formula and the structural formula given a name of a compound like this one, where we are not given numbers. Now from there, let's have another example. This time we'll look at how can we write the structural formula where maybe we have this bute, then we'll say we have 2ene. So now how do we deal with this one whenever we are given a number? So this number indicates the position of the double bond. So let's first look at the formula. Even though you are given number or not given number, the formula must be applied the same. So the formula is CnH2n. So we can remember that but has 4 carbons, so we put the 4 carbons. So this means that where there is Ne is equal to 4. So C times 4 is C4. Then 2 times 4 we have 80 atoms of hydrogen. Now we can first begin by writing the 4 atoms of carbon. Now this time we are not going to put the double bond wherever we feel like putting it. This time we need to put this number into consideration. So what this means is, if we count from left to the right, this is our carbon 1. So we have, this is our carbon 1, our carbon 2, our carbon 3, then this is our carbon 4. So if we count it from the left side going toward the right side, our double bond should be located at carbon number 2. So this is what it means whenever you see a number. So we can now proceed. So we are going to have 1, 2, 3, 4, 5, 6, 7, 8. So that is the picture whenever you have a particular number. So let's try one more where we have been given the location of the double bond. So let's say we have hex 1 in. So let's first begin by writing the chemical formula. So we use the general formula, so CnH2n. So from the prefix of hex, we can see that n is equal to 6. So here we have 6. So C times 6 is C6. 2 times 6, we have 12 atoms of hydrogen. So we can write the 6 carbons. So 1, 2, 3, 4, 5, 6. Now let's say we number it from left going the right side. So we have carbon 1, 2, 3, 4, 5, 6. Then what if we maybe number it from right to left? So this is our carbon 1, 2, 3, 4, 5, 6. So if we are numbering it from our left going to the right side here, our carbon 1 is here. This is our carbon 1 is here. So that is where our location of the double bond should be. But if we decide to count it from this side moving to the other side, then our double bond would be this one, because our carbon number 1 will be considered to be only this position. So this is what you do. So the point is, whenever you see a number, the number indicates the position of the double bond. So you can choose either. The answer still remains the same. So let's consider we'll look at it from left to the right side. So this is what our double bond is. Then here we are going to have 3 bonds. Then let's put the hydrogen. So we'll have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is our 12 atoms of hydrogen. Now, away from how to write the molecular and structural formula, let's move on. How do we name some of the members of this family? So we'll first look at this example. So the question is, we'll just say name the following compound. The first compound that we are going to name is this one. Okay, so this is our compound that we want to name. So whenever you are asked a question to name a particular compound, first we need to look at the prefix. The prefix is just the number of carbons. Then the other one, we'll look at the suffix. So the suffix will tell us the type of bond that we have. Is it single bonds, or do we have a double bond or a triple bond? Then from there, we'll need to look at the locant of double bond. Where are the double bonds located? Then from there, we'll look at how many double bonds do we have. Okay, so now let's look at the first thing. We'll look at the prefix. So let's count the number of carbons that we have. So 1, 2, 3, 4, 5. So we can see that we have 5 carbon atoms. So the prefix for 5 carbon atoms, remember we said is pent. Then from there, the suffix, let's look at the type of the bond. We can see that we have a double bond. So at least there is one double bond. Whether there are 3, 4, as long as there is a double bond, then the suffix should be E-N-E. Then let's look at now the position of, or the locant of the double bond. So first we are going to count it from the left going to the right. So this one is carbon number 1, 2, 3, 4, 5. So if we move from left to right, we can see that the first double bond is on carbon 3, the second one is on carbon number 4. Now let's check from this side. So this is carbon 1, 2, 3, 4, 5. Okay, so now let's look at which numbers are we going to use. So if we move from left to right, we can see that the first double bond is on carbon number 3, the second one is on carbon number 4. Then if we move in this direction, we can see that the first carbon is on carbon 1, then the second carbon is on carbon 2. So we have 1 and 2 and 3, 4. Now, since we have different numbers, which numbers are we supposed to use? So the numbers that you are supposed to use, you need to use the lowest number. So in our case, we are going to use 1, 2. So that is the pattern. So we have 1, 2 is our locant or location of the double bond. Then from there, we are going to look at now how many double bonds that we have. So from the structure, we can see that we have 2 double bonds. So whenever we have 2 double bonds, we are going to use di. So that's a pattern. So di, that is 2 double bonds, di, 3 double bonds, tri, 4 tetra. So that's a pattern that you need to have in mind. Now let's look at the final answer in terms of the naming. So the naming, you begin with the prefix. So we have the pent. Then from the pent you have this hyphen. Then you need to indicate the numbers. So the number, you look at them according to their ascending order. So the lowest number is 1, comma 2. So the pattern is between the numbers you put comma, but between the word and the number there is this dash line here. Then from there we are going to put another comma. Then we are going to put die, which means that we have 2 double bonds. Then from there we add the suffix e and e. So this is how you name a compound like this. Okay, so then let's try another one. This time let's say we have 1 2 3 4 5 6. Okay, so we'll say we have the double bond is here, and also we have like this. So we can try. So you can feel free, pause the video and try to give it a try. So what do you think are we supposed to do for a particular problem like this? So the first step, we are going to identify the prefix. Then the second one, we are going to look at the suffix. Then after the suffix, we'll look at the locant. Then from the locant, we'll look at how many double bonds do we have. So let's first look at the prefix. So we can count. We have 1 2 3 4 5 6. So whenever we have 6 carbons, the prefix is hexy. From there, the suffix, we can see that we have a double bond here. So as long as there is 1 or 2 or 3 double bond, then the suffix is ene. Then we can now look at the locant. So number from left, we have 1 2 3 4 5 6. Then so if we number it from this side moving, we can see that the first double bond is on carbon number 2, the second carbon on carbon 3, then the third double bond on carbon 4. Now let's try the other direction. So consider 1 2 3 4 5 6. So if we number it in this direction, the first double bond is on carbon number 2. So it's 2 comma, then we have 3, then also we have 4. Now we can see that each either of the two directions we are getting the same numbers. If we move from left to right, we are getting 2 3 4. Then also the same, this is giving us the same number. So if you have a particular situation like this, you can choose any of the two directions since you are getting the same number. So the locant will say is 2 3 4. Then our final name here, we are going to have hex, sorry. So we are going to have x, then we have hyphen slash, then 2 3 4, then another hyphen. Then let's look at the double bonds that we have. We have 3 double bonds, so we add tri ene. So this is the name of this particular compound. Okay, now away from how to name this particular compound, let's look at how do we deal with isomers of alkenes. So we can look at now the isomers of alkenes. Now isomers of alkenes can be treated into 2 ways. The first one can be treated by branching isomers, where you have a branched carbon, or the carbon has moved from the main chain, or where you just have to look at it. We have the carbons are arranged in a straight chain. The only difference is the arrangement of the double bond. So let's look at what we are looking at. So first, begin by giving the names of these molecular structures. So we'll begin by, we'll have this structure number 1. Okay, so this is our first structure. Then the second structure, we have this structure here. Okay, so now we have been given these two structures. So we are not going to rush into conclusion of saying these two are isomers. The first thing that we need to do is, first we need to look at their molecular formula. Are they the same? So let's first look at the first one. So let's look at the formula for this one. Let's count the number of carbons that we have. 1, 2, 3, 4, 5. So we can see that we have 5 carbon atoms. So let's move on to structure B. So structure B, we look at how many carbons we have. 1, 2, 3, 4, 5. So we can see that we also have 5 carbon atoms. Since we have checked for carbon atoms, now let's look at the hydrogen atoms. So the hydrogen atoms will have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 5 carbons, 10 atoms of hydrogen. Now let's check here. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So even here we have 10 atoms of hydrogen. So we can see that their molecular formulae are the same. So these two qualifies to be isomers. So that is what you need to first look at. You need to check if they have the same molecular formula. It's not all about the structure. If the molecular formula are different, therefore they are not isomers. They are just different kinds of the molecules that you are dealing with. Okay, now since we have indicated or proved that these two are isomers, let's now name the first one. So begin by naming the first one. So we said we'll first begin by, we need to look at the prefix. So the prefix, we just have to count the number of carbons. So from the chemical formula here, we can see that we have 5 carbon atoms. So the prefix is spent. Then from there we need to look at the suffix. The suffix, we can see that we have a double bond, so it is E N E. From there, let's look at the locant. The locant of the double bond. So if we number from left, we have 1, 2, 3, 4, 5. So if we number from left, the double bond is on carbon number 1. Then if we number it from right, we have 1, 2, 3, 4, 5. So in this direction, we can see that the double bond is on carbon number 4. So since we have the idea, we know that under this one, we are going to use the direction that we are going to use is this one, since it is giving us the lowest number. So here we are going to have 1. Now from there, we can check for the number of double bonds that we have. So from this one, we are going to see, we are able to see that we only have one double bond. So our name for this one is pent 1-ene. So this is our name. Now let's look at the other one. So let's look at the other one. We have a different situation, because we can see that there is an alkyl group. There is one branch. I mean, there is one part that is branched. So this is a branched one. So this is a branched one. It is branched because it is moved away from the parent chain. Then our parent chain, this is our parent chain, because it is where we have the many carbon atoms. Okay, now from there we are going to first begin by, we need to look at the branched. So from the branched party, we can see that we have one carbon. So the prefix for one carbon is meth. Now for a branched, you always add YL. So for those that may want more of these, you can check from the first video about the alkenes. Now, so we now continue. So for the branched, we are saying you need to first identify the prefix. After that, you need to add YL to whatever prefix that you have come up with. Now, here we need to look at the location. We are going to look at two locations. The first location that we are going to look at is the location of the branched. Then we'll look at the location of the double bond. So let's look at this one. The first one, I'm looking at the location of the branched one. So if we count from here, we have 1, 2, 3, 4. So we can see that if we move from left to right, the branched is branched on carbon number 2. So it is on carbon number 2. So if we move in this direction, it's on carbon number 2. Now let's check if we move from right towards the left side. So if we move from there, we can count 1, 2, 3, 4. We can see that it is on carbon number 3. So this direction will give us on carbon number 3. Then remember, we said that we always use the lowest number. So this 2, we'll choose 2. 2 is lower than 3. So we'll choose 2. So we're going to put 2, comma. So the number in front of an alkyl group indicates the position of the branched one. So we are done with the branched. Let's move on to now the parent chain. Now from the parent chain, we'll look at the prefix. So just have, it's like we are naming two parties here. We have named the branched one. Now we need to move on. We need to move on to the parent one. So just name it the way it is. But under the parent now, we'll just consider the location of the double bond. So from the parent side, we can see we have 1, 2, 3, 4. So we can see that we only have 4 carbons. So we add BUT. Then from there, location of the double bond. So we can see that if we number it from left, we have 1, 2, 3, 4. So we can see that it is on carbon number 1. So we just say but 1, then E-N-E. So this is the name of this particular compound. Okay, now let's try another one. So we'll say we have, so the previous one, this is what we call the isomers, where we have a branched one. Now if we move on to the next one, let's say we have this one. Okay, so then we'll have this one. So from these two structures, are these two isomers? So we don't know if these two are isomers. What are we supposed to do to check? First, let's check their molecular formula. If their molecular formula are the same, then they are isomers. So let's begin by counting the number of carbons. So we have 1, 2, 3, 4, 5. So we have 5 carbons. Then we count hydrogen. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 atoms of hydrogen. Okay, so it is C5H10. Let's check for the other one. So let's count 1, 2, 3, 4, 5. Okay, so we also have 5 carbons here. Then let's count hydrogens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So even there we have 10 atoms of hydrogens. Okay, so these two are isomers since they have the same molecular formula. Now, what kind of isomers are we dealing with? We are dealing with what we call positional isomer. How do you know that this is a positional isomer? We can check the arrangement of the carbon atoms. So we can see that all the 5 carbons in this structure 1, and the way they are arranged, the carbon atoms are arranged exactly. There is no atom of carbon that is branched. So this is what we call the positional isomer. Now, if the carbon atoms are arranged the same, then what makes these two become isomers? So we can look at the location of double bond. The double bond on this for structure A is located on carbon number 1, but for structure B is located on carbon number 2. So what I'm saying is, if we number it, we have 1, 2, 3, 4, 5. We can see that the first double bond is on carbon number 1. But if we number this one, 1, 2, 3, 4, 5, we can see that this time the double bond is on carbon number 2. So that is what we call the position isomer. So where the double bond is located. So these are the two types of the isomers that we have under alkenes. Now, what if we want to name these two structures? So look at the number of carbons we have is 5. So we have pent. Then it is double bond is on carbon number 1. So we have 1. Then we only have 1 double bond, so it's pent 1. Now for this one, we are going to have pent. Then the double bond is on carbon number 2, so we have 2 ENE. So this is the difference. So the only difference is the location of the double bond. Okay, now we can move on away from the isomers. Let's look at some of the chemical properties of alkenes. So the first chemical property of alkenes, they undergo combustion. So combustion is a reaction of an alkene, or maybe any substance with the oxygen. So if we say we have this structure, if we have an alkene member plus we react it with oxygen, the products are carbon dioxide, and water plus energy, but we just consider carbon dioxide and water. So this is a combustion reaction. It doesn't matter what kind of an alkene have you used. You can use even if you use ethene, propene, butene, pentene, mention as many, the product will always be carbon dioxide and water. or it doesn't matter how many number of carbon atoms are there in an alkene, the product should be carbon dioxide plus water. So this is what we call the combustion. So whenever you have a reaction or a statement of what happens if you react an alkene with oxygen, then the answer should be carbon dioxide plus water. Now from there, the other chemical properties, these alkenes, they undergo what we call addition reaction. So an addition reaction is just a reaction in which a small molecule attaches itself to the double bond. So now let's look at what are we talking about and what is our first step. So the first chemical process that we look at under chemical property of addition is hydrogenation. Now the question is, what is hydrogenation? So hydrogenation is just defined as the addition of hydrogen to an alkene to form alkane. So we'll first begin by, let's look at word equation. So if we have an alkene where we have ENE, then we react it with hydrogen. The product will be alkane. We are going to produce the one with ANE. So that is the picture that we have. So for example, if we have ethene plus hydrogen, then we are going to have ethane. We are going to have ethane. So that's the pattern. If it is propene plus hydrogen, you have propane. Butene plus hydrogen, you have butane. So what we are saying is, whenever you react an alkene with hydrogen, the double bond breaks from the alkene to form an alkane. So that is the part, regardless of an alkene that we are using, all the alkenes, they follow this pattern. So let's use, we have used the word equation, so we can also use the chemical equation. So the chemical formula for ethene is C2H4 plus the hydrogen is diatomic, so we have H2. Then here the number of carbon atoms will not change, but these 2 hydrogen and the 4 hydrogen will add up to 6. So this is what we are saying. For structure equation, you can remember that we said the structure for ethene is C, where we have a double bond. So we have hydrogen here, then also hydrogen here, another hydrogen. Then this is reacting with hydrogen. So hydrogen is bonded to hydrogen with a single bond. Now we are saying as long as it is hydrogenation, the double bond must break. So we are going to have the single bond. So one of these 2 double bonds, so one has broken to form the other two bonds where the 2 atoms of hydrogen are added onto. So that is the picture. So that we have 1, 2, 3, 4, 5, 6. So to summarize this chemical property, we are saying whenever we add hydrogen to an alkane, alkane must be formed, and this process is known as hydrogenation. Now you also have to know that this process occurs in the presence of a catalyst. So the catalyst that we may have is nickel. Okay, now let's move on to proper number 2 for addition. So we have hydrogenation. So the alkenes, they undergo not hydrogenation but hydration. So hydration is also known as hydrolysis. So this is just the addition of water to an alkene to form alcohol. So let's look at the word equation. So the word equation is, if we have alkene, then we react it with water. the product should be alkano. An alkano is an organic alcohol. For instance, we can use ethene plus water. The product should be ethanol. If this was propene, then the product would have been propanol. So that's a picture. Butene, the product butanol. Then for a structure of first, let's look at the chemical formula. So ethene, we can say it is C2H4, then water is H2O. So what happens is, if we break water into ions, water is same as hydroxide and the hydrogen ions. So what happens to this hydroxide? So the hydrogen will be added on these 4 atoms of hydrogen. So we are going to get C2H5. Then this hydroxide will be attached here. So this is what we call the molecular formula for ethanol. But for structure, we have this, plus we have water. Then we are saying the double bond must break. So if we have now the single bonds, make sure each carbon must have 4 bonds. So we put 1, 2, 3, 4, 5. So this is where our 5 hydrogen is. Then the remaining bond here, we attach the hydroxide. So this is what we call hydration or hydrolysis. So it is just the addition of water to an alkene to form an alkane. Then the catalyst here can be acid. So it can be acid. We can use acid like sulfuric acid. It can be used as a catalyst under this chemical reaction. Now, from there, we also have another addition chemical property. Now, this time we'll look at halogenation. So, halogenation. Now, what is this halogenation? So, from the word halogenation, we can see that there is this word of halogen. Then halogens are elements from group 7 of the periodic table. So then what is this halogenation? So halogenation is just an addition of a halogen to an alkene. So for a picture in terms of word equation, let's say we have alkene plus let's say we had halogen. Halogen can be chlorine, bromine, iodine, any. Then the product should be haloalkane. So if we have ethene plus ethene, let's say we have, what can we react with? Let's say we have chlorine. So then now for the product here, we are going to have dichloroethane, since we have 2 atoms of chlorine. Now let's look at the chemical formula. So we have C2H4 plus chlorine is diatomic. Then for dichloroethane, the number of carbons atoms will not change. Here we cannot change the hydrogen and the chlorine. So these 2 are different. So the number of hydrogen atoms will be maintained, but this carbon should be attached to this structure after the double bond has broken. Then for the structure, we have this double bond here. Then for chlorine is bonded to another chlorine through a single bond, since the chlorine has a valence of 1. Then here we are going to have the first one. You begin by considering the carbon atom, so we only have 2 carbon atoms, and the double bond has broken. Then we have 1, 2, 3, 4. So I have indicated the 4 atoms of hydrogen. The remaining is the 2 atoms of chlorine. So we can put our chlorine here, also here. So it doesn't matter where you write these chlorine atoms. So that is the picture for this dichloroethane. Now we can look at the other chemical property that we can look at is addition polymerization. So addition polymerization is just the addition of alkenes to form one long polymer. What do we mean? Let's say we will have an alkene plus another alkene. Maybe we can say we use 3 alkenes. Then this will be considered to be monomer because they are smaller. So we have 3 monomers. Now, what is the name of the polymer that is going to be produced? So the polymer, whenever you're trying to name the polymer, you begin by first you write the word poly. Then after writing the word poly, since the monomers are the same, you just get one monomer. So this will be polyalkene. Okay, so what do we mean? Let's say we use the monomer ethene plus ethene plus another ethene. So what is the name of this particular polymer? This polymer is polyethene. That's a picture. If the monomers were to be butene, the polymer would have been polybutene. So that's a pattern that you need to follow whenever you're looking at addition polymerization. Now for chemical equation, so you can see the pattern. I'm beginning with the chemical equation, word equation, chemical equation, and the structure equation, so that you may have the picture of what is happening here. So the chemical equation is we have C2H4 plus C2H4 plus C2H4. Then how do you write the chemical formula for a polymer? So we first add the number of carbons together. So from this the first one, we can see that we have 2, 2, 2. So the total number of carbons for these 3 ethenes will have 6 atoms of carbon. Then let's add the hydrogen. We have 4 plus 4, 8 plus 4, 12. So we have 12 atoms of hydrogen. Then in terms of the structure, we know the structure for ethene plus another one. Then since there are 3 plus another one. Then what you need to know is after this polymerization, the double bond should be broken into single bonds. So we are going to have single bonds between the 6 carbons. Then how many hydrogens do we have? We have 12, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now you can see that we have two bonds that have no hydrogen atom. So these two bonds must just be written like this. So what this means is we can add more of these monomers if we want to. So these should be just left like that. Doesn't mean maybe we have made a mistake. No, we just leave it like that. So it just means that we have more room to add more. We can add more of these alkenes in terms of the monomers. We can also summarize these three. We can write them like this. So we can just write one. So in some textbooks you may see something like this, then you see the N here. So the N indicates the number of the monomers that you are going to use. So for instance, we can see that we use 3, so we can put 3. Then this means that we have 3 of this structure. So it's the same pattern. We just wanted to maybe show you what is happening here. So this is how you can show the addition polymerization. So polymerization is just the adding of smaller molecules to form a large molecule. So we can see that this is a large molecule formed from this small molecule. So that's it for this video. So if you are new to this channel, consider subscribing, and don't forget to hit the notification bell so that you are notified as soon as I post new video. Thanks for watching.